Hello everyone, this is Mitch Israel, and for today's video, we will talk about physical properties. So in physical properties, there are many examples. Some of them are density, specific gravity, state change temperatures, and electrical conductivity. So let's discuss each examples. First to discuss is density. So density of a material or substance is defined as the mass per unit volume. It is represented as the ratio of mass with volume of a material. It is denoted by P. Then the density of a material has a formula. Density is equal to mass over volume, where P is the density and M is the mass and V is the volume. So iron, platinum, and lead are examples of dense materials. Many types of rock and minerals are examples of dense material. So materials that are dense are most likely to feel heavy or hard. The opposite of dense is sparse, and a few examples of sparse material are glass, bamboo, aluminum, and styrofoam. So in general, liquids are less dense than solids and gases are less dense than liquids. So this is due to the fact that solids have densely packed particles. Liquids are materials where particles can slide around one another. And gases have particles that are free to move all over the place. So I have here sample problems of density. So number 1, you have a rock with a volume of 15 cm cube and a mass of 45 grams. What is its density? So the given kay na ay volume which is 15 cm cube and mass is 45 grams. So for solution, we can use the formula of density which is P is equal to M over V. Substitute the given and we can get the answer of density is equal to 3 grams per cubic centimeter. Number 2 example, you decide you want to carry a boulder home from the beach. It is 30 centimeters on each side and so has a volume of 27,000 cubic centimeter. It is made of granite which has a typical density of 2 grams per cubic centimeter. How much will this boulder weigh? So we have a given V 27,000 cubic centimeter and density 2.8 grams per cubic centimeter. So ang gipangita is ang mass. So we can solve this problem using formula nga sa density which is P is equal to M over V. Substitute the given and money shot. P, ang density is 2 grams per cubic centimeter and is equal to M over 27,000 cubic centimeter. So we can use this, we can calculate this using calculator. I-shift solve lang, makuha na nimo ang mass which is 75,000 grams. Number 3, sample problem. Rocks are sometimes used along coast to prevent erosion. If a rock needs to weigh 2,000 kilograms in order not to be shifted by waves, how big does it need to be? You are using basalt, which has a typical density of 3,200 kilogram per cubic meter. So given M is 2,000 kilogram and density is 3,200 kg per cubic meter. So, ang gipangita is ang volume. So, solution, P is equal to M over V. Substitute the given. 3,200 kg per cubic meter is equal to 2,000 kg per V. So, shift solve sa calculator. V is equal to 0.625 cubic meter. So now, let's proceed to specific gravity. It is defined as the ratio of density of material with respect to density of a reference material or substance. It does not have any unit. Sometimes it is also called as relative density. For gravity calculation, generally water is considered as a reference substance. The formula of specific gravity is equal to density of the object over density of the water.
So I have here some of the materials and their specific gravity. So for cement 3.12, wood ash 2.57, fine aggregate 2.59, coarse aggregate 2.76, glass aggregate 2.35, and water has 1. So now let's proceed to the other example of physical property, which is state change temperature. So generally a substance has three states called solid state, liquid state, gaseous state. So state change temperature is the temperature at which the substance changes from one state to another state. There are three state change temperature: melting point, freezing point, and boiling point. Melting point is the temperature at which the substance changes from solid state to liquid state. Freezing point, it is the temperature at which a liquid changes from liquid to solid state. Theoretically, it is equal to the melting point. While boiling point, it is the temperature at which the substance changes from liquid state to gaseous state. So last na example na ako i-discuss sa physical properties is electrical conductivity. So electrical conductivity is a measurement of how easily a material allows electric current to flow through it. Inversely, electrical resistivity measures how strongly a material resists the flow of electric current. Electrical conductivity is denoted by the Greek letter sigma. Good conductors of electricity are also often good conductors of heat, as evident in most metals. So the temperature of a material can affect its conductivity in a not so straightforward manner. For materials known as conductors, an increase in temperature generally decreases their conductivity and vice versa. But for insulators, the reverse is the case, as an increase in temperature actually increases their conductivity. This relationship between temperature and electrical conductivity is useful in creation of superconductors. A superconductor is a material that conducts electricity almost perfectly, with virtually no resistance whatsoever. So far, all known superconductors require extremely low temperatures to exhibit this property. Units of electrical conductivity. So electrical conductivity is denoted by the symbol sigma and has SI units of Siemens per meter. In electrical engineering, the Greek letter K is used. Sometimes the Greek letter Y represents conductivity. In water, conductivity is often reported as specific conductance, which is a measure compared to that of pure water at 25 degrees Celsius. Relationship between conductivity and resistivity. Relationship between conductivity and resistivity is electrical conductivity is the reciprocal of the electrical resistivity, where sigma is equal to 1 over P, where resistivity for a material with a uniform cross-section is P is equal to RA over L, where R is the electrical resistance, A is the cross-sectional area, and L is the length of the material. So there are materials with good and poor electrical conductivity. Metals and plasma are examples of materials with high electrical conductivity. The element that is the best electrical conductor is silver, a metal. Electrical insulators such as glass and pure water have poor electrical conductivity. Most of the non-metals on the periodic table are poor electrical and thermal conductors. So the conductivity of semiconductors is intermediate between that of an insulator and a conductor. Examples of excellent conductors include silver, copper, gold, aluminum, zinc, nickel, and brass, while the examples of poor electrical conductors include rubber, glass, plastic, drywood, diamond, and air. So that is all for my report. Thank you for listening. Bye.